This video is from a touch typing competition, and the guy called Sean has won the competition by typing 124 words per minute. Raise your hand if you can touch type. Keep your hand raised if when you touch typing you're pressing the keys with the correct finger, if I could say like that. I have a friend, and when he is touch typing, I've noticed that his right hand is one row offset to the right. So whenever he needs to press the keys Y, H, and N, he has to move his hand and type those keys, and then he move it back, and this is the way he types. And I thought, well, when I was learning how to touch type, I was learning how to do it like correct way. And I was wondering if there is a way not to learn how to press the correct keys, but also have a feedback when you're learning whether you're pressing those keys with the correct finger, if I could say like that. My name is Tetiana Dushenkivska, and I'm here today to share my journey on building a touch typing system. To build a system, there are a few steps you should go through. So you need to have a text to type. Also, you need to record the key press events, which are coming from a keyboard. Recording finger events, so you could tell with which finger you're pressing the keys. Then you have to get it all together, analyze it, and return the result. Okay, let's build it. Let's talk about architecture and what the parts of this system could be and what we are going to use to build it. To display the text, I'm going to use the browser because I know how to do that. To record key press events from a keyboard, that's easy, JavaScript. Okay, now it's more interesting to record finger events. So here is when it gets nice. We have, so I'm using Arduino, C, and a bunch of sensors, but I'll come back to this on a later stage. And to analyze events, what could it be? Well, this is an Alexia conference, so of course it's going to be an Alexia. But when this project started, it was on a hug day, and I had my Alexia part, which was doing all of the analyzing and getting the events together. It was all built as one massive application, which had Phoenix, all the logics, everything together. It worked, but when I got submitted to a talk, I thought, okay, this is not quite right. And I was lucky to join Informatics. This is the company I'm working for, full-time with Alexia, very excited. Informatics specializes in combining monitoring, modeling, and control of water supply networks with embedded computing and data management, resulting in integrated solutions for resilient, adaptive, and calm networks. What that means? Put it simply, we help water companies prevent bursts and extend the life of the water network. And when I joined this company, I've seen that the way they're structuring their code is that they're having a lot of umbrella applications, and each umbrella application responsible for its own piece of work to do. So I thought this is a good idea, and I should do that because it sounds good. So I have structured my application into 3 umbrella applications. It was, to start, a little bit hard to choose how many applications am I going to have, what's going in which application, and what's going to be responsible for what. So then I had key events. Okay, so to register them and pass it through, I could use a Phoenix. This is good. So then I had to read somehow, interact with the Arduino. And I use Serial for that, and this is its own responsibility. And then the logic part is responsible for getting those events and analyzing them together. If you noticed, the Phoenix logo look nice there. It wasn't like that to start with. When I was first in the cafe drawing this architecture and preparing for the talk and thinking what the parts are, this is how the Phoenix logo looked like. You may have recognized it because Keith has printed those stickers and then given them away. But this has come up from that drawing of architecture in the cafe. So the full architecture looks like that. We wouldn't stop here for one time. Let's better move on to implementation. So we need to have our project, and we are creating a new project which contains umbrella applications. We sit inside the project, create our first umbrella application. In this case, it's going to use Phoenix. We call it type Hero Web. I was very surprised and happy to see that in Orlando, Chris has mentioned that Phoenix now is changing the structure, and they're going to call the application which contains Phoenix Web. So Phoenix Web, type Hero Web. I thought this is good. I'm on track. Then you fetch the dependencies. Here it's running, good. And now let's talk about the messages, so the data flow. So once we render the browser, we have to send the message to the Phoenix channel to join, and we return an OK. And then as the result, just to show our user that the game is loaded and ready to be worked with, interact with, we just show in render a start button, which looks just like that. So this is, you probably have seen this code. So on a JavaScript, we define a socket, we connect to the socket, we connect to the channel. Notice the name of the channel, games lobby. Then we join it, and then when we have our the result back, then we start our game. Okay, we are connecting to the lobby channel, but we don't have it yet. Let's create it. Games lobby, this is the message we are passing, so we're making sure that this is the message we are also passing much on. And once we send a join message, we return an OK and a socket. And this is how it looks. So at the moment, I just log into the console. OK, so when I press, so when we join the channel, we get our start button, and then the next step would be to, when we press that start button, then we are in the game, ready to play. So let's do those steps with clicking on the start button and getting into the game. So when we click that start button, it sends a message to a Phoenix channel, start game, which is passing it through to the core. And the core is my logic piece. So what Phoenix is responsible for is just to collect the events and pass it through. It's not doing anything with the events. So it passes it through to the core, to the logic piece, and the logic piece is then going to decide what to do with that. The logic piece would know about the text to render, so it asks what it should be, returning the text, and then as the result, we render a text on the screen. And this is how the JavaScript may look like. So when we get the event, we stop displaying our start button, then we push the message to the channel. And our channel is listening to that message, and once it get this message, then it's going to call our logic core piece to get the text, passing in the socket, because, well, it could be done differently, but the way I did it here, I needed a way to Phoenix to communicate with another umbrella applications. And I could send messages to core logic application, but I needed a way to talk back somehow for this core application to send messages back if it needed. So to communicate, it needed to know how. So providing the socket, it allowed this communication to happen. So we get the text back. Our logic piece is another umbrella application, so we need to generate another application, initialize it, which is just going to return a text. It's hard-coded here, but it could be fetched from actor or get from somewhere else. If you noticed here, the socket is empty because when the application starts, it doesn't know anything about socket, but it will on a later stage when we do our first code to this application. And then we start game. So we are listening to this message on our logic part. We get a text, and we now have a socket, so we just save it to the state so we could communicate on a later stage. For one application to be able to communicate to another, we need to add it as a dependency. So we are adding our core application dependency. And then we just render text to the screen with the JavaScript. OK, so this is that part done. So we could show up the text on the screen. Now we could collect the key events. The way it happens is when someone presses the key, we get a message from Phaser with a key and ID. Phoenix gets this message. All it's doing is just passing it through to the core application, and the core application passes through to the event handler. And the event handler is the guy who is collecting all of the messages which are coming from the Arduino with the finger events and from the keyboard. And it's going to tell us as the result whether it matches, not matches. So to send the key event, we just push the key with ID to the key channel, to the channel with the key message. And then we're listening to that message, and we get the key and ID, event, and socket. Well, we're not passing through, we just have it in a state. And then we call our key press function, which lives in the logic part. And that key press function is responsible for passing the key and ID to the event handler. OK, so with this in place, we could say that we could send the key events to the logic part, and this is part of our architecture is implemented, and we could move on to the next part. The next part is sending finger events. So to be able to do that, I needed to look at the ways how it's possible. So I looked at lip motion. I've looked at a different way of trying to record your finger movements. But it was very hard to track whether you actually press the key. Like you could see that the hand is moving, is great, but you can't really tell whether it's pressing the key or not. So then I got to a little bit simple solution, which was having a sensor on each finger, which is going, if you touch it, then it becomes conductive, and then it could send the signal saying that you have pressed this sensor. To have a sensor on each finger, it makes sense to have it in a glove. Otherwise, it's a little bit hard to get it on your fingers. And all the sensors, they're connected to Arduino ports, and they send the signal. Let's talk about building the sensor. It involves a few parts. Velostat, which becomes conductive when you apply pressure on it. Conductive material. I didn't know much about all of the wearable electronics like a year ago, but then we went to a hack day, which was about wearables, and there was so many interesting things like conductive materials, threads, and things you don't even need to learn how to solder. You just sew things together, plug them in the Arduino, and it works, which I thought is quite a cool thing. So to build the sensor, you have to put this velostat, which is this the black thing you've seen, between two conductive materials. And you should make sure that the velostat between those two conductive materials are big enough so the conductive materials not touching each other, because if they do, then you would have a corrupted signal, which you don't want. And you could see you could build it pretty small, so I just put this sensor next to my finger, and it's quite tiny. So you put it together, and the next thing is this guy. So you need to connect it to Arduino to be able to read the data from those sensors. This is not too hard. All you need to do is connect one end of the sensor to one of the ports. Sensors usually are sending analog signals. So if you connect it to analog port, you'll send the correct data. There are some components which are sending digital signals, but make sure that with the sensors, usually they'll be sending analog ones. So pick up one of the analog ports on Arduino, and another part of the sensor, another end, it should go to the power. And when you have the connection with which goes to the analog port, it should also go to the ground. If you forget the ground, it's not quite good. It doesn't work. Okay, and to tell Arduino that it's supposed to be reading those the data which is coming from sensor, you write a little program which is saying that, okay, I'm using the analog pin, A0 in my case, but it could be any. And then you just read the value coming in. So it's going, in this case, if you see the serial print, it's just going to print whatever value comes in. And this is how it looks. So here I'm just trying to press this sensor. So whenever I'm not touching the sensor, the values are around 10. And then whenever I apply pressure, it's around, 600. And it also, the values are increasing more you apply the pressure. Okay. The problem with that program is that if you keep holding the pressure, then it will keep sending the values. But if you want to just register the event once, you need to make sure that you have some condition checking that whenever someone triggered or pressed the key, just register it once and then register it again when they take it off and press it again. So you don't have the events coming constantly. You don't need that. And with that one pressure, you have to build five those sensors, put them on a glove, or add a little bit more of C code. So you have the code for each finger, each sensor. And with that in place, you could then test it and see if it's working. Now this is my little test. I'm trying to press the keys, and this is the values I get. So it's just sending the number 1 or 2, depending with which finger I'm pressing, or which sensor is sending the value. Okay, and this is the part which registering the finger events done. But at this point, it's quite satisfying that you could actually get it in, which allows you to, it brings you more energy to carry on and see it all working together. So then you're moving on to the part which I was really wanted to work with, the Alexia part. So once all of the JavaScript and, well, sensors were exciting, okay? The JavaScript are sensors and Alexia part. So before I jump into Alexia part, let's talk about the terminology I'm using so we could follow through the code snippets. So when I say finger, I mean the finger number which comes from the Arduino. So it will be just numbers like 1, 2, 3, depending on the finger. And depending how you count it, so in Ukraine, we are counting 1, 2, 3, but in England, I've seen people counting from these fingers, so it's a bit confusing. Then the key is the event which comes from the keyboard. So this is the key pressed on the keyboard. And the letter is the current letter in the text which you're supposed to be pressing. So all of the matching logic is going to be against the current letter. Okay, let's talk how we get those events to our event handler. So it's pretty straightforward. We have our Arduino. Then there is a library which allows us to interact with Arduino. And we are getting, with the help of that library, we get the event from Arduino, then we pass it through to the core, and this within this part, we also log in the event number, or ID. So we know the number of events which coming through. So then whenever we get two events together, having ID from one event and another one, we can then do our match. So we get this to the core and pass it through to the event handler, and then event handler is going to do all of the hardcore stuff, trying to say whether it matches or not. Okay, the app we are missing. So we need this another umbrella application, which I called Type Hero Serial. And I have a serial library as a dependency. When I implemented that with the serial library, it's good, it's working, but now it's outdated, and you have to be using Nerve's URT library, but in this talk, I'm still using serial library. And if you Google serial library and you open up the README page, it has a link to the new URT library, which is helpful. Not before the talk, but helpful in general. Then we need to add our co-application as a dependency, so we could talk to it. And then our serial umbrella application could talk to our Arduino and get the values coming in from it. It's important to see that the port you are using is the one you are using to connect to the Arduino. If this one is not the right value, then it's not going to work. So just make sure you could see it in Arduino ID which one you're using. Just check that it matches and you're using the right one here. So then you connect to it. The next step is to actually get the events. There is a function helper, which is going to just take the data the way it comes in and pass it into the core logic part. I had to match on the number because I had the coming in sometimes like end of line characters or empty lines. So I had to make sure that I'm matching on this with the regular expression, and then I'm passing only the number of the finger to the core application. Okay, and now is the last piece, but the important piece, the core umbrella application. So we get events from the serial, the finger events, get them to core. From core, we get them to handler. And then within the handler, what we're going to do is we are going to have a look whether we have the event with this ID already or not. If we do, then we're going to do some match. If we don't, then we just store it. So when in the similar way happens from the key event. So we have the event coming in, and then goes to the handler, and then we're doing the logic part, saying whether it match or not match. To talk more in detail about that, so let's say we have some text to type, and we press the letter with the finger, and the signal came first from the finger. And it's going to, there is a condition there which is going to see whether we have this key for the ID which in the finger in the map. So if we do, then we could pick it up and see if it matches or not. If we don't, that we don't need to do anything. We just store it into the map and wait till we get the same event with this ID coming, so we could proceed. So in this case, we have two events coming from Arduino with the finger number, and we don't have the same events for the key events with the same ID. So all we're doing is just storing it into the map. Okay, what happens next? We get the event from the key, and we are going to see if the relevant event from the finger with this ID exists. So we are getting here ID 0. So we're looking, do we have the event, finger event with ID 0? Okay, yeah, we do. So let's pick it up and then pass it to process and say if it matches or not. So we take it out from the map. It's not the easiest thing to walk through, but I'll try to do my best to explain. So we are picking up the finger from the map, and then we are going to say, if this finger matches to the letter we're supposed to be pressing. Okay, if yes, then we still do the next match. We just remember the result of it. Does it match to the key match to the current letter? Okay, let's remember the result. And then depending on all of those conditions, we'll have different types of the result, which would be that you pressed the letter you're supposed to be pressing with the correct key, correct finger, or you just press some random things on the keyboard, which is not much, which is easy to understand. And then the one which is a bit more tricky is that you could have pressed with the wrong finger, but correct key, or it could be that you pressed with the right finger, but wrong key. So this is all comes to the result. The results, 4 of them. Okay, so there are a few functions which help to do that. So I don't have here the actual custom call function because it's something we could skip, but what happens here is that once we get our key event, we pass it to the handler, and then when we have our finger event, we also pass it to the handler. And the handler is the one who is going to do the decision about match. So there is an event struct, which is going to add the key events when they come in, and the finger events when they come in, if ID doesn't exist. Then we initialize it just with an empty map or struct. Then when we have the event, we try to if we get the key event, we try to see if we have relevant to that finger event. The result of this could be either nil if the key doesn't exist, or an actual event. So if we have, so then we pass the event or nil, the result of this, to the process key function. And in the process key function, we are pattern matching on the result. So if we don't have that event in the map, then we just add it to the map, so it's there. If we do have an event, then we have to do our match. So we call match all function. And what match all function does is just collect all of the things it needs to match, and so it's key, finger, ID, state, and pass it to our, well, there is a module matcher which is doing all of the match. And we also, the current letter, we are getting from our higher level, so we have to code to it to get the current letter, so we could pass it to the matcher. So with those three, we'll get a result. What happens in the matcher module? Let's go through this. So we have our match function, which is accepting key, finger, and letter. And the match key is going to say whether key or letter match, so it's true or false. And similar for the finger, it's going to say true or false. The thing is, with finger, how would it know whether whether this finger is mapped to this key? So there is a map with finger numbers, which I just created myself. But ideally, you could, if you want to learn a different layout, and you know that the keys are placed a little bit differently, you could construct this map yourself if you want to learn a different layout. But I've used QWERTY one. So then we get the key from the map. And then we're going to tell whether they match or not match. So it's going to return true or false. And the result of total match is going to be one of the atoms, which is all match, no match, or some of it match. So then it returns the result. At the moment, we're just inspecting it, but we'll come back to it. And you have to, after you've done the processing, you have to make sure that you cleaned your map, so you don't have those events that, well, if your map grows, then it's not going to be easy for you to fetch the events in the future, so you try to keep it small, so you clear it up with the events you've processed. So you delete the event. This is pretty straightforward. You just pass what to delete to the map. Okay, and then you just remember to return no reply, because this is a handle cast. Okay, this is good. So the next step would be to notify the UI of the result. The way it happens is that when you get the result, you pass it to the core. Then from there, you pass it to the Phoenix channel. Phoenix channel then pass it to the phaser, and phaser renders the result to the browser. So we call even handler result to our call function, passing in the result, which is an atom, and the ID. And we are listening to that message in our higher level module. And here, we have to remember that if a person has pressed the correct key, correct finger, then we have to remove this current letter from the text. If he has made a mistake, then we should keep the text as it is. So here we just checking, and making sure that we're removing it. We just take it out from the text if it's correct. Okay, and then we get the result. And we broadcast it to the socket. We have sockets in our state, so we use that. And then we render it to the UI. Okay, let's see how it's all working together. So I'm highlighting green the letters which I get correct. And then yellow is the one which made a mistake, but pressed the wrong key or finger. And if everything is wrong, I highlight it red. Like that. Okay. And this is the end of the talk. Let's summarize it. So when people talk about Alexia, they often say that Alexia is functional, fault-tolerant, distributed. And I think they're missing one adjective, which is inspiring. Before Alexia, I didn't really have too many side projects, but once I started playing with Alexia, I had lots of ideas, and it's been really fun. If you get to play with hardware, especially when you plug in together software and hardware, then it becomes really fun. And if you feel like you want to have some fun hacking on things, plugging hardware is pretty rewarding. Another thing is whenever you structure your application, your system, think about the umbrella applications and think about the parts you can pull apart into its own logical pieces and think how they may interact. And to think how they may interact, it helps to draw those data flow diagrams. I was struggling when I separated the umbrella, defined what each umbrella application is doing. I was struggling to define the API for each application and what it's going to pass, but drawing those diagrams helped a lot. And that's it. Thank you very much. This project is available on GitHub, and I'm on Twitter. Thank you.
Hi. Cool talk and lovely project. I was wondering, did you tend to find whether you were getting the key events or the finger events first and whether they kept swapping around? Or I was just wondering, is it faster coming from JavaScript or were they faster coming through the serial?
It depended. Sometimes it came from the JavaScript that had like a few events, and sometimes the finger events were delayed, but another time had the other way around. So I couldn't really say. It was just like randomly coming in.
Is there another question? Okay. How did you deal with uppercase letters because you have two finger events and one key event?
Yeah, that's a good question. So I don't deal with those things, and I don't deal with things like when the key events come in becomes unsynchronized for some reason. So it was just a happy case project.
Thank you.